Okay, so today we are going to talk about, or we are going to have a summary of module 2. So first of all, I will just remind you again, I've said it a couple of times now, you learn the most of the course content in the textbook and the Jupyter notebooks that we have on the GitHub. So use them, it's important. So last week and this week, the plan is that you should work with the 3 first notebooks in the module. So 2.1, 2.2, and 2.3. Then in next week, you will work with 2.4 and 2.5, which is about decision trees and ensembling and random forest and boosting. So the concepts we have been talking about this week. And you have also some extra notebooks that you can look at if you have time. And I will recommend you to do that. So here is the schedule for presentations next week. And I have put it out on Canvas and and also on Discord. So if your group is not on this list, let me know. So I will prepare some videos to next week. So watch them and work with the notebooks during the time you don't have presentations. Okay, so we are going to have a summary of this module with using a library called Picaret. So Picaret is an open source low-code machine learning library in Python that helps you from data preparation to model deployment. So I made a recording yesterday. Since some of the things take some time to run. So I think we can start with this video. I'll look into it. So we will look at how we can get the data, setting up the environment in Picaret, select models, hyperparameter tuning, combining all models, and analyze the results at the end. And finally, export the model. So after that, we will look into the source code, how Picaret works, since you are, of course, software engineering students. So first, we start with using this Picaret.dataset to import get data. So here you can find a lot of data sets that you are known with, like the diabetes dataset and Titanic, among others. But in this tutorial, we are not going to use those. We are going to use something you are more familiar with. The housing price dataset you are working on in this assignment. So we will just import the data first here by getting the directory. So then you will get the data from reading it from a pandas data frame as a pandas data frame. Then you have the directory and the train.csv that you should be familiar with. So, okay, then we can look at how the data looks like. So, you have all the features and values, and then we are going to the next step, setting up the environment in Picaret. So here we start with importing the regression module in Picaret, since this is a regression task, right? So then we set up using this setup in Picaret. So the data is the data set, and the target value is the median house value. So so just type that in. Then we'll just define the training size. We want to use the entire training data, as I mentioned several times earlier. So we are going to use cross-validation, and we have to do some imputations. So to fill out the non-values, and here we are going to use median values. And we are also going to normalize the data by using a method in Picaret called robust, which works better for, let's pause the video there. So it works better for features with outliers. So here, when you run this, you can see that you get out this data types for each of these features, and you can see the longitude, latitude, and so on is numeric. Then you have ocean proximity is a categorical feature, and you have the median house value is labeled. So if that's correct, then you can just continue, and it will process the data for you. Then you get up more information if you have missing values in there, how many numeric features, categorical features, many more things in there. Okay, so that's it. That's everything you need for pre-processing the data. Then we are going to select models. So in Picaret, you have several models that you can use, as you can see in this list. So you have random forest, linear regression, and many more other models. So the next thing we are going to do is train all of these models to find the best models. So to do that, we can use this method called compare models in Picaret. And we can set number of models we want to get in return. And we want to sort it by root mean squared error. Oh, sorry. Let's see. Back to there. Okay. There. Then we start the training. And we get some warning there. So that's convergence warning when running the example, which can safely be ignored. Okay, so you see that it still trains, and it compares all the models. Yeah, and you can see the final result with cross-validation. Yeah, we can take out to look at which are the 4 best models. So yeah, that's those 4. Then we can start with hyperparameter tuning, which is the next step. So it takes some while to do this on especially random forest and all the others below. So we will just do this on one of the models. So we will do that with the best model here. So yeah, that's the reason why we pick index 0, right? But you can do this for all the models. So you can, instead of just writing best model 0, you can just give in the whole list. And we want to optimize it by root mean squared error. So it runs this to find features that are based on some default values in Picaret. Then you see that with fine tuning, it gives better performance. We can also define our own models and make our own grid. That makes sense in some cases or tasks where you know which values that would make sense to give in instead of using default values. So here's just to show you how we can do that. So just look at this method create. We will look into this method create model later in this video. So, but yeah, here you can see that we can give in a custom grid. So KNN has this and neighbors you can define. So that's what I'm doing here. Okay, then running kpoll, then fine tuning, yes. Okay, then you can also combine these models that you have trained with a blender. So as we talked about in the lectures yesterday with stacked models, so you can have predictors. So those could be the best tuned models, but I'm just giving in here the best models. And the meta model could be one of those models. Yeah, so here I'm just giving in the first model. Okay, but I will not run it here in this tutorials, and since it takes some time to run it. Okay, so the final thing, it's quite cool. You can just write plot model and give in the model that you want to look the results on. And here you get the residual plot for your model. Then you can also look at the error plot by just typing which type of plot you want. So yeah, here's the error plot. And finally, if your model supports feature importance, you can also plot that and look at this feature importance and go back again and see if you can remove some of the features and make the model even better, or the training time goes at least down. So after that, you can just export the model by writing save model. So it will save the model and the pipeline, as the text will show now. Okay, so let's go into the source code. So if you start with it's a regression task. So we go into this first file. So we are in the pick array library now. Then we go into the regression. Then we are going to look into finding create model method, as we can find here. Then if you go in here and look further down, we can see that it's going into something called internal tabber create model supervised. So then we are going to look into that folder with internal tabular data. And if we continue to dig into there and search for this method with creating model supervised, we can see that it is something called all models internal there. And if we go into that one and click into it, we can see something there called regression. Okay, so in there we can see it stands containers, models, regression, get all model containers. So let's go into that folder and see what's in there. Yeah, so in here, if we just go down, linear regression container, if you look at that, it's only using scikit-learn model, the linear regression model in there. And we can also look into other models and see what they are using there, decision trees. And here is the grid they are using for their random, when they are tuning their models. So that's it. Isn't that quite simple? Or yeah, so don't use this for this assignment one. It won't accept that. But for assignment 2, it's allowed to use this library. So I made a tutorial on GitHub, as you can see here. So it's in one of the notebooks. So if you take git pull, you will get this notebook. Okay, so that's it about, sorry, 2 messages here on Slack. Sorry, if you couldn't see this video, I have put it out on YouTube as well, so you can look into it later on. Sorry. I can answer the questions at the end, but let's continue with this. Okay, so the next part will be the module 3, where we are going to look into machine learning in practice. So yeah, we will take some steps towards understanding the big picture. So real world machine learning production systems contains a lot of, what should I say? It's a large ecosystem. And as I mentioned in the beginning of the course, it's not possible to cover all these components. But as it's standing here, we're going to take some steps into that. And when we talk about machine learning in practice, it would be interesting to hear how they do this in the industry. So therefore, I have invited the head of data science department at Bouvet, Paul Reyersgaard, to give us a lecture about how they do it. So that will be so after the presentations and so on, and in October. And we are also lucky that Alexander Lundevall will give us a guest lecture in November about medical imaging and deployment there. So so you can see that the machine learning code pod is only a tiny component in this large ecosystem. So here is a more complete workflow than we have seen earlier. So you start with the big picture to get an understanding of it. Then you get the data and do all this feature engineering and so on, and the modeling that you have been working on. So these two components, you're familiar with these two components. So the third part is deployment. And this is potentially the most challenging stage. And this is what we are going to look into in this module. So we want to go from this Jupyter notebooks to production. So companies care about machine learning models that actually creates value for their customers. You cannot just assume that customers know how to use Jupyter notebooks. So the full value of machine learning models come from enabling others to use them. So there are different types of libraries that can help data scientists to do this. For example, this Flask and also Voilà. Voilà is a library that can be used to convert notebooks into a standalone interactive web dashboard application. And you can deploy like these applications into Heroku for free. So let's look at one example of how I have done it earlier for a deep learning project. So this is a segmentation tool, so predicting pixel-wise in an image or classifying pixel-wise. So for a radiologist or a doctor, it won't make sense to use a Jupyter notebook. So if you give them something like this, it will make more sense to use this deep learning model. So this is one way you can do this in this assignment too. So another thing when you talk about deployment and getting machine learning models into production is you have to try to avoid, or you should avoid, disaster. So here's an example of this. Google's medical AI was super accurate in the lab. In real life was a different story. So Google tried to put their algorithm for detecting diabetes into clinical workflow in Thailand, and their algorithm sometimes failed to give a result at all. It was designed to reject images that fell below a certain threshold of quality. And also poor internet connections in several clinics also, of course, delays. More questions there. Okay. Okay, let's continue. I can answer the questions at the end. And also here's more examples. So Amazon scrapes AI recruiting tool that showed bias against women. And also Google here again. So think about this when you develop your algorithm. So how can we avoid these disasters or mitigate? So here are 3 steps from a course I took earlier where they talked about in deep learning, where they talked about these 3 steps. So you start with a manual process to have a human that checks all predictions first. Then you put it into a limited scope. So you like geographical or time-related scope, then gradually expand this system and think about what could go wrong on this way and what kind of biases you have in your model. Okay, and this comes to that, yeah, your assignment 2, playing the whole game. So this will be a kind of iteration 2 on your assignment 1, but this time you can select some other data sets that I put it out on Canvas, and I will recommend you to make something you can be proud of. So you can, for example, use it for when you apply for jobs, where you can put this in your GitHub repo or something. And I was also thinking about having some prize for the best group, or yeah, and it was coffee mugs. I was considering that, so let me know if you are up for the challenge. So okay, so here are some tips to how you can start with this project. So you have to have a good, a nice README file on GitHub project. So here's some important things that you should have in your README file. So what your project does, how to install it, example usages, and how to set up the development environment, and many more things here. And you can also use this cookie cutter data science library to make folders, so it gets more structured, as you can see here. And you should put this into your README file. Yes. So here's an example from a project I did last year. So put in like pictures, videos, GIFs that makes it more easy to understand what your project does and how to install it and so on. So yeah, don't be afraid to include images, GIFs, videos. Okay, so finally, test your code. Test allows you to have confidence that your code functions as expected, and that when you make changes, you didn't actually break anything. So we will talk more about these principles in module 3. So now it's time for questions, and I got a question on Canvas yesterday. So we can start with that. So I know that I can understand that you are a bit confused in combining pip and conda. So here's a link to best practices checklist. So, but when combining conda and pip, it is best to use an isolated conda environment, like the .158 environment. Then you activate this environment and install as many requirements as possible with conda, then use pip. Imagine that you have several projects and they require different libraries and different version of those libraries, then it will make sense to do this. Okay, so we have 3 weeks left of machine learning. So next week it's going to be a presentation, and I will make some recorded videos for the tools I mentioned, like Voilà and Flask, and putting that into Heroku, and you should start on assignment 2. So in week 43, we are going to talk about deployment. And yeah, we are going to have a guest lecture from Boé. And in week 44, we are going to have a guest lecture with Alexander, where he's going to talk about machine learning in medicine. And I will prepare some exam questions that you can work with. In week 45, you should hand in assignment 2. With that, I think I can stop the video and you can ask the questions you are wondering about.